Okay, number 9, there is nothing that we can do to simplify this. It's quotient rule all the way. So remember, you start with the low function. All right, so the low function as is e to the 40x. And now we need the derivative of the high function. That is going to be a chain rule, okay? The outer function is cosecant, the inner function is 10x. So the 4 comes along for the ride. The derivative of the outer, the derivative of the cosecant, is negative cosecant cotangent. All right, so that's the derivative of the outer. We have to put the inner as is in both places. So we put 10x here, and we put 10x here. And don't forget, the derivative of the inner is 10 times 10 on the end. So that whole mess is the derivative of the high function. Again, this is the derivative of the outer, negative cosecant cotangent. The inner as is goes in both places, 10x, 10x, and that's the derivative of the inner. Okay, we come back with the high function as is. So 4 cosecant of 10x. And now we need the derivative of the low function. That is also going to be a chain rule. The outer function is e, and the inner function is 40x. So the derivative of the outer is e to something. The inner as is 40x, and the derivative of the inner is 40. That is a big mess. All right, on the bottom, we take the denominator, low, e to 40x, and don't forget you always square it. So that is the quotient rule. Now we're going to simplify it. We're going to simplify each term in the numerator. Okay, so up here, the first term, you've got a negative 1, you've got a 4, and you've got a 10. So we're going to put the negative 40 out front. All right, we still have an e to the 40x. We still have a cosecant of 10x. And we still have a cotangent of 10x. All right, for the second term over here, we've got a 4 and a 40. So we need to put the 160 in the front. We multiply them. So we have 160. There's still an e to the 40x, and there's still a cosecant of 10x. All right, on the bottom, we simplify the exponent. When you're raising one power to another, you multiply. So that becomes e to the 80x. All right, now we are going to factor the numerator. All right, so we look for common factors on each side of the numerator. And I'm just going to start highlighting them. There's an e to the 40x on each side. We can factor that out. All right, there is a cosecant of 10x. We can factor that out. And we can also factor out a common factor of 40 and 160. All right, so I'm going to factor out a 40. So we put the common factors out front. I'm going to factor out a 40. I'm going to factor out an e to the 40x. And I'm going to factor out a cosecant of 10x. And then I'm going to rewrite that binomial. All right, so when we're pulling out common factors, we divide. If I divide this term by my common factors, negative 40 divided by 40 gives me a negative 1 out front. The e to the 40x's are going to cancel out. The cosecant of 10x's are going to cancel out. I'm left with a cotangent of 10x. Now I'm going to divide my second term in my numerator by my common factors. 160 divided by 40 gives me a 4. Everything else cancels out. The e to the 40x's cancel out, and the cosecant of 10x's cancel out. So there is my factored numerator. Now I bring along my denominator, e to the 80x. The last thing to do now is to cancel with the numerator to the denominator. You've got an e to the 40x and you have an e to the 80x. So you will have e to the 40x left on top. All right, so when we simplify it, we have 40 cosecant of 10x times negative cotangent of 10x minus 4, and it is all over e to the 40x. And that is as far as you need to go. That is a lot. Go through that on your own. Okay, number 10. This is a double chain. You've got 1x, but you have 3 functions. The outermost function is the secant. The inner is everything else, cosine of 4x. You need all 3 functions accounted for in that first chain. So you put the outer here, and there has to be 2 here. Now this is still a composite function, so we go again. The outer function there is cosine, and the inner is 4x. Okay, so we get started. Remember, on the first chain, we only do the first 2 steps. So the derivative of the outer, the derivative of the secant is secant tangent. All right, so that is a big, long derivative of the outer of your first chain. All right, now we put the inner as is in both of those places. So we put the cosine of 4x here, and we put the cosine of 4x here. That's your second step, the inner function as is. You put it in both places. And that is everything that we do for chain number 1, only the first 2 steps. Now we start over and we go to the second chain. The derivative of the outer there is negative sine. So that is the derivative of the outer. We plug in the inner as is, 4x. So that's the inner as is. And don't forget, multiply everything by the derivative of the inner. You need the last step of the chain rule on the last chain, times 4. So that is the derivative of the inner already, and this is your second chain. That is a lot of parts. Oops, that's chain number 2. Over here is chain number 1. Hello. Okay, so now let's simplify this guy. All right. So t prime, what goes out front? Well, we've got a negative 4. We got to get the negative 4 out front. So we still have a secant of the cosine of 4x. We still have a tangent of the cosine of 4x. And then we also have a sine of 4x. There you go. Best full credit simplified answer. Okay, in number 11, we are not covering this in distance learning, but this is a Pythagorean identity. You would simplify this first. That simplifies to negative 1. All right? So then if we took the derivative m prime of x, the derivative would be 0. But don't worry about that. We are not covering it in distance learning. Okay, number 12. We got a little bit of a simpler one here. This is my outer function. This is my inner function. That is a chain rule. All right, so the derivative of the outer, the derivative of cosine is negative sine. There's the derivative of the outer. All right, we plug in the inner as is, x to the third. So that is the inner as is, and don't forget we multiply everything by the derivative of the inner, 3x squared. That's a power rule. All right, so that's the derivative of the inner. To simplify this thing, we've got to get that 3 out front. So we put negative 3, I'm going to put the x squared with it, and then sine of x to the third. All right, that was a lot easier. Number 13, again, rewrite it. Okay, that 3 right here, that applies to everything immediately to the left and to the right of it. That is the same as the cosine of x all cubed. Then we can definitely tell this is a chain rule. My outer function is something to the third. My inner function is cosine of x. 2 functions, 1 chain. G prime of x, the derivative of the outer, is 3 times something to the second. That is the derivative of the outer, using the power rule. I plug the inner as is in there, cosine of x. Okay, and don't forget we multiply everything by the derivative of the inner. The derivative of the cosine is negative sine of x. So that is the derivative of the inner. All right, when we simplify, we've got to get this negative out front. So I'm going to rewrite it. Negative 3 sine of x times the cosine of x squared. There you go. Okay, number 14, remember this symbol here is the Leibniz notation, d squared y dx squared. It means find the second derivative. So we have to find the first derivative first, simplify, and then go again. All right, so to find the first derivative, hey, this is a simple trig function. We know that the derivative of the secant is secant x tangent of x. All right, so we're done. Now to get to the second derivative, we need to take the derivative of this. There's nothing to simplify. That is going to be a product rule. All right, this is my first function, and I'm multiplying it by the second function. You see the letter x twice, two separate functions multiplied together. So for the second derivative, that is going to be the product rule. All right, so let's set it up. The first function as is the secant of x. Now we need the derivative of the second. The derivative of the tangent is secant squared of x. All right, then we come back with the second function as is, the tangent of x, and we multiply it by the derivative of the first function, which is secant x tangent of x. All right, now we can simplify this thing. All right, this term here, secant of x times secant squared of x, gives us secant cubed of x. Over here, we can combine the two tangents. So I have a secant of x times the tangent squared of x. All right, now I can factor. All right, what's common to each of those terms? Well, there's 3 secants here, and there's 1 secant here. So I can pull out a secant, only one. You pull out the smallest power that you have. All right, so when you pull out a common factor, you put it in front, secant of x. Then you rewrite the binomial and you divide. I divide this term by this term and put it here. Secant cubed of x divided by secant of x gives me a secant squared of x. And then when I divide this term, secant of x tangent squared of x, by my common factor, the secants cancel out, and I'm left with a tangent squared of x. And that is as far as you need to go. Thanks, calculus.